chapter 9, which is called Quadratics, right? The goal today is that you're going to be able to identify A, B, and C of a quadratic, figure out the direction, the minimum, the maximum, the axis of symmetry, its vertex, and its y-intercept. Sounds like a lot, but a lot of this goes pretty quick. Let's see if we can try it here. All right, first off, we have graphing quadratics basics. Okay, so quadratic looks like this: ax squared, that's the quadratic term, plus bx plus c. Okay, we know the a, b, and c terms from factoring. C is going to be our constant term. And if we scroll down a little bit here, it looks like we have our parent graph, which is just x squared, okay? So what we could add on to that to make it kind of make sense is if I were to say, if this is my a, I could add plus 0x plus 0, my a, b, and c term, okay? So if these are 0, they're of course are going to go away, and we're just left with x squared. All right. A couple things. The axis of symmetry is a line that goes through the vertex and divides the parabola, or that's another name for a quadratic, into two symmetric parts. All right. So in this case, it'd be the y-axis here. All right. That divides it perfectly into two parts. The vertex is going to be either the highest or the lowest point of a parabola. It's always an ordered pair, so in this case it's 0, 0. All right, here's a quadratic function, ax squared plus bx plus c. It opens up if a is greater than 0, or if a is positive. It opens down if a is negative. Okay. In our original parent function, y equals x squared, this is a positive x, so it opens up. The shape of the graph is more narrow than the graph y equals x squared if the absolute value of a is greater than 1. Okay. So things like 4, negative 10, the absolute value of that's all greater than 1. And it's wider if the absolute value of a is less than 1. So like 0.75, 1/2, things like that. The axis of symmetry, and we're going to practice this all later, so don't get too overwhelmed right now, but the axis of symmetry is just the line x equals negative b from our a, b's, and c's earlier, negative b over 2 times a. The vertex has a coordinate of x equals negative b over 2a. So once you find the axis of symmetry, you found the x coordinate. And then to find the y coordinate, you're going to plug that in, whatever x equals. So like if x equals, this becomes a negative 4, for instance, you'd plug in negative 4 to your original function, and what spits out would be the y value of the vertex. And then lastly, the y-intercept. To find that, we're just going to plug in 0 for x, and whatever that gives us will be our y-axis. So it would be in the point 0, c. So oftentimes it's our c term. All right, let's practice this a little bit. Example 1, we have our a, b's, and c's. A is negative 2, b is 3, and c is negative 4. Just like factoring, that comes from here, a, b, and c. To do examples 2, 3, and 4 quick for you. Example 2, we have 4, negative 7, and 9. Example 3, this one's missing the b term, so we could say this is x squared plus 0x plus 3. So we'd have 1, 0, and 3. And similarly, example 4 is missing the c term, so if I add a plus 0 at the end, we have negative 1/2, negative 4, and 0 for the c. All right, so does it open upwards or downwards, and does it have a maximum or a minimum? You'll notice here that if it opens up, let me just draw one. Okay, that opens up. This is going to have a minimum value, right? These keep going up and up, but this one is stuck right there. Nothing is going to go below it. All right, so let me erase that. And let's see. Same thing for the negative. If it opens down, it's going to have a maximum. The y-coordinate of the vertex is the minimum or maximum value. Okay, so let's try this here. This is going to be a positive 3, so it's going to open up. And since it opens up, it's going to have a minimum. In example 6, this is a negative 2 for the A. It's going to open down. Since it opens down, it's going to have a maximum. To find the axis of symmetry, if we remember, the axis of symmetry is going to be the equation x equals negative b over 2 times a. All right, so we're going to use that to find our axis of symmetry. In example 7, negative b is going to be negative 12. Divided by 2 times our a is 3. So negative 12 over 6, which equals negative 2. Right, and I should write this like this. X equals negative 2 is the axis of symmetry. In example 8, the same formula, negative b. Since it is negative 12, a negative negative is going to be a positive 12. Over 2 times a is negative 3. So here we have 12 over negative 6, which is negative 2 again. And we would end up with x equals negative 2. Okay. In example 9, our b is lots of 12s. Oh my goodness. We have negative 12 for the opposite of our b, or negative b, divided by 2 times negative 2, 2 times a. That's negative 12 over negative 4. A negative over negative is a positive. 12 divided by 4 is 3. So this is x equals 3 for its axis of symmetry. Example 10. This one is missing the b term. All right, so I could rewrite this as x squared plus 0x minus 3. So negative b, well, there's no negative 0, so it's just 0 over 2 times a, 2 times 1, and 0 over anything, of course, is 0. So the axis of symmetry on this one is x equals 0. Find the y-intercept of the graph given the function. Okay, the y-intercept I said earlier is what y equals when we plug in 0 for x. I'm just going to write that up here. Plug in 0 for x. So if I were to rewrite this, I'm just going to do it for this first one, and it should become easier after that. But if I plug in zeros for all these x's, this is going to all become 0. 0 squared is 0. 0 times 7 is 0. Plus 12 times 0 is 0. Minus 8. So y equals 0 plus 0 minus 8, or those cancel, and we're just left with negative 8. So y equals negative 8. And then we do want to write this as an ordered pair. So again, x was 0, y is negative 8. I'll put that in a box. Try for example 12. Again, hopefully you can see all of this is going to become 0. All this has become 0, and we're just left with that positive 5. So y is going to equal a positive 5. And if we want to write that as an ordered pair, it's going to be 0, 5. I think that's a little bit easier than plugging it in and rewriting it each time. In example 13, maybe we can just see right off the bat that y will equal negative 4.5 because this becomes 0. So if that's true, then our y-intercept is 0, negative 4.5. Okay. So let's try it out on all of these. First off, a on this one is going to be -2. Oops. Let's try this. -2. B is going to be 12, and C is -7. Does it open up or down? This one is going to be opening down because it was a -2 for the A. The axis of symmetry, remember, is -b over 2 times A. So in our case, that's going to be a -12 over 2 times -2. -12 over -4. Negative over negative is positive. This is +3. We want to write that as x equals 3. It's actually the line. X equals 3 is the axis of symmetry. To find the vertex of this one, we want to plug in 3 in for all the x's, because the axis of symmetry always cuts through the vertex. So our x value, I can even put that down right now, x value is going to be 3. But we're trying to find what this y value is. So if I plug in 3 for all these x's, that should give me what y equals. I'll even write y equals -2, and I'm going to leave these blank in place of x. I'm just rewriting that quadratic, and I'll plug in 3 for all those blank spots. Do it with a different color. Okay, and if I plug this in the calculator, looks like I get 11. So I'm going to plug in 11 for my y spot there, and that is the vertex. Okay. The y-intercept, letter E, remember we plug in 0 for all those, and it's only left with the constant is, our C term. So here our y-intercept is going to be -7, and we want to write it where x is 0 and our y is -7. Does this one have a maximum or a minimum? Well, since this opened down, it's going to have a maximum. Circle maximum. And then value, you will not need to do the value on your assignments, so we'll cross that out. Let's try another one. Go a little quicker this time. A is going to be 1/2, B is 8, and C is -9. This opens up because A is positive. The axis of symmetry is going to be -b over 2 times A. This is -8 over 1, which is just -8. I'm going to write that as x equals -8. To find the vertex, I'm going to plug in -8 for all those x values there. And when I do that, looks like I get -41. Whoa. -41. So we want to write that as the point -8, -41. The y-intercept is going to be -9. It's our constant value. And we want to write that as a point, so I'm going to say 0, -9, so when x is 0. This one has a minimum because it opens up, and we do not need to do the value. All right, and that is it. Okay, so we'll stop there for today.